Hey everyone, today we are going to solve the daily LeetCode challenge of 5th April 2024 and the problem statement is make the string gray. So let us first understand the problem statement. So according to the problem statement, we have been given a string S such that it contains English alphabets in both uppercase as well as in lowercase, correct? So we can see that this S is containing alphabets in capital, like we can see that there is a capital A and there is a small a. So it contains alphabets in both the cases, correct? Now what we have to do is we have to make the string great. Now, what is a great string? So a string is called great if it doesn't contain two adjacent characters such that one of the character is a lowercase letter, whereas the other character is the same letter in uppercase or vice versa. So what does it mean? It means that if we are given a string S such that this is the ith index and this is the I plus 1th index. Okay. So if the character present over here is in lowercase, okay, and the character present over here is the same character. Same. What do I mean by same character? It means that let's say over here it's A and over here it's capital A. Okay, so it has same character but in uppercase. Correct. So what does it mean? It means that in that case, this string is not a great string. Correct. Because it has been clearly mentioned that if one of the adjacent character is in lowercase and the another character is the same character in uppercase, then it is not a great string. Correct. So if we have something like this, then it is not a great string. So let's take an example. So if we have C, A. So we can see that what are these characters? These two are the same characters, but in the opposite cases, that is, this is a small a and this is a capital A, correct? So these are in opposite cases. This is in lowercase, this is in uppercase. So this is not a great string. Similarly, if we have A, then again, this is in uppercase, this is in lowercase. These two adjacent characters are the same characters, but are in opposite cases. So it's not a great string. Now, is this a great string? So this is a great string. Why? Because both these adjacent characters are same, correct? This is also A, this is also A. But both of them are in the same cases, that is, both are in the lower cases. So it is a great string, correct? Similarly, if we have something like this, then it's also a great string. Why? Because both of them are in upper cases, right? They are not in opposite cases. So if we have adjacent letters in opposite cases, correct? That is, one of the character is in uppercase and the another character is in lowercase. Additionally, they must be the same character, right? So let me add it over here. Same adjacent characters in opposite cases, then it is not a great string, correct? It is not a great string. Now that we have understood what is a great string, now what we have to do is we have to make a string great if it is not great. So how we can do it? We can do it by simply removing the part which is making the string not great. Like here, if we take this example, then we can see that this is not a great string. Why? Because here are the two adjacent characters such that they are the same characters but in opposite cases. So it means this is not a great string. So we have to make it great. So how we will make it great? We will make it great by removing the part which is not letting it to be great, correct? So which is the part which is not letting it to be great? It's this small a and capital A, right? Because of these two characters only, it's not a great string. So what we will do, we will remove these two. So what we'll get? We'll get only a capital C from here. Similarly, if we'll see this example, then it's also not a great string. Why? Because we have a capital A over here, we have a small a over here. So both are A, but in opposite cases. So it means it's not a great string. So what we will do, we will remove these two in order to make this great. So what we'll get? We'll get a capital C, correct? So if we have something like A, B, C, D. So what we can see? We can see that this one and this one is not letting this string to be great. Why? Because what we have over here, we have a capital C and we have a small c. That is, both of them are C, but in opposite cases. So it means that it is because of this string is not great. So what we'll do, we'll remove this. Additionally, these two are D's, but in opposite cases. So what we will do, we will remove these two as well. So what we will get? We will get AB, correct? Now that we have understood that what is a great string and how can we make a string great, correct? Now let's see that what string we will get after making this S a great string, okay? So this is the string S. So what we will do is, currently we are over here, okay? So we will consider this U. Then after that, we'll consider this A, okay? Because till now this string is great. Why? Because we can see that this is U, this is A. They are not the same letters, right? So this is great as of now. Then we'll move forward. So we have got a B. Now, till now, it's a great string, okay? Then we'll move forward. We have got a capital B. Now, The moment we will add this capital B over here, what will happen? We will have two of the same letters but in opposite cases, correct? So whenever we have adjacent letters that are same but are in opposite cases, then what it will do? It will make the string not great, right? It will make the string bad. But what we want? We want a great string. So what we will do? We will remove it. And how we will remove it? We won't add this capital B and we will remove this B. Why? Because of these two, the string will not become great, correct? So we will remove these two. Then what we'll do, we'll move forward. So we have got a capital C, we will add it. Till now, this string is great, correct? Now we have got a small c. Now, if we will add the small c over here, then what will happen? So we can see that this is small c and this is capital C, correct? So both of them are C, but they are in opposite cases. So if I'll add the C over here, what will happen? This string will not remain great. So what we will do is, we won't add the small c over here and additionally, we will remove this capital C, correct? And we will move forward. So I have got a capital A. Now, if I add this capital A over here, then what will happen? Now we can see that this is a capital A. And what is its adjacent letter? So its adjacent letter is the small a, correct? Both of them are A, but are in opposite cases. So if I'll add this capital A, then this string will not remain great. So what we will do is, we won't add this capital A and additionally we will remove the small a, correct? And after that, we'll move forward. We will get this S and I'll simply add this. Why? Because on adding this as, this string will still remain great, correct? So what we will get? We will ultimately get U and a small s, correct? So this is the string that we have made, correct? So this is a great string that we have made from this S, correct? Now my question is that which data structure should we use in order to solve this problem, correct? You saw that how we were storing these values and what all operations we did. So which data structure comes in your mind after seeing this? The answer to that is stack. Why? Because what we are doing, we are iterating over the string S and what are we doing? We are pushing the values until our string S is valid, correct? And the moment we get a pair which is making it invalid, that is which is because of which the string will not remain great. So what we are doing, we are starting on to popping it, right? And we can notice the same pattern while solving all the kind of parenthesis problem, like what we used to do. If we have a parenthesis like this, so if we get an opening bracket, what we used to do? We used to push it. We get an open bracket, we'll push it. We get an open bracket, we'll push it. Now, the moment we get a closing bracket, what we do? We pop it. The moment we get this closing bracket, what we do? We pop it. The moment we get this closing bracket, what we do? We pop this, correct? So what we will do over here? Over here, we will follow the same approach, but what would be the case? Say, for example, if I have something like C, A, B, B, D, okay? So I got this C, I'll push this C. I got this A, I'll push this A. I got this A. Now what we can see? We can see that this is a capital A, but this is a small a. So what these two are A, but in opposite cases. So it is making it invalid. So we will pop this. Then I'll move forward. This is a B. I'll push this. This is a B. So we can see that this is a capital B, but this is a small b. So these are B's, but in opposite cases. So we will pop it and we'll move forward. We got a D. We will add it. So what is the final answer? The final answer is TD, which we are getting. Correct? So we will use stack in order to solve this problem. Now let's quickly do a proper dry run over this string S in order to understand this in a better way. So initially we would be present over here and let's say that this is our stack. Okay, so what we will do, we got a U and initially our stack is empty. So whenever we'll find out that our stack is empty, what we will do, we'll simply add this U, correct? Now we'll move forward. Now we got a small a. Now we'll check that since this is a small a, so we will check, is this the top value present in our stack? Is it capital A? So we can see that this is not capital A. So what does it mean? It means that if I'll add the small a, our string will still remain great. So what we will do, we will add the small a. So now what is the top value of our stack? The top value is the small a, correct? Now we'll move forward. So we got a small b. Now what I'll check, since this is a small b, so if we will have the top value as capital B, then it will make our string not great, correct? That is, it will make our string bad. So we will check, is the top value capital B? So the top value is not capital B. So what does it mean? It means that if I'll add the small b in our stack, our string will still remain great, correct? So I'll add the small b and now our top will be this small b, correct? Now what I'll do, I'll move forward and we have encountered a capital B. Now since this is a capital B, then what does it mean? It means that since this is a capital B, if the top value of our stack would be small b, then what will happen? If the small value would have been small b, then our string will become a bad string, correct? So we will check what is the top value. The top value is small b and we have capital B. So if I add this capital B to our string, then what will happen? Our string will not remain great anymore, correct? So what we will do is we won't add this capital B and we will simply pop out this small b, correct? And if I pop out the small b, what will happen? Our top will now point back to the small a, correct? Now we will move forward. So we have got a capital C. Now since this is a capital C, then what does it mean? It means that if the top value would be small c, then our string will not remain great. So we will check what is the top value. The top value is a. That is, it's not small c. So what does it mean? It means that if I add this capital C in our string, it will still remain a great string. So what we'll do, we will add this capital C and now the top value would be this capital C, correct? Now what we will do, we'll move forward. So what we have got a small c. Now since this is a small c, so what does it mean? It means that if our top value would be a capital C, then our string will not remain a great string. So we'll check what is the top value. The top value is capital C and this is the small c. So what does it indicate? It indicates that the adjacent characters are the same characters but are in opposite cases, correct? Because of which the string will not be a great string. So what we will do, we won't add the small c and additionally we will pop this capital C, correct? Now since we pop this capital C, our top pointer will again point back to this A, correct? And we'll simply move forward. Now we have encountered a capital A. Now since this is a capital A, so what does it mean? It means that if the top value of our stack is small a, then what will happen? Our string will not remain a great string. So we will check that what is the top value. The top value is small a and we have capital A. So it means we are having similar adjacent characters but in different cases. So it means that if I add this capital A, then my string will not remain great, correct? So what we will do, we won't add this capital A and additionally we will pop this small a, correct? So if I pop this small a, then what would be our top? Our top would be this capital U, correct? And then I'll move forward. So I have got a small s. Now since this is a small s, then if our top value would be capital S, then it will no more remain a great string. So we will check, is the top value capital S? So we can see that the top value is capital U. It's not capital S. So what does it mean? It means that if I'll add the smallest to our string, then it will still remain a great string. So we will add the smallest and now the top will point at this smallest and we'll move forward. Now we can see that we have clearly processed all the value of this S, correct? Now what we can see that what is our answer? So if we will see over here, we have U, A, B, B, C, C, A, S, correct? Now we can see that this B and this B will contribute in making our string not great. So we will remove it. Now this C and this C will also make our string bad. We will remove it. Now since we remove this part, now the adjacent part will become this small a and this capital A. And because of this, again our string will not remain great. So what we will do, we will remove this one as well. So what we got US, correct? And how we can get it? We can get the top value is S and after popping this top value, we'll get this capital U and this is our answer, this US, correct? So how are we going to populate our answer? So we can take an answer string, which would be of the same size as that of our stack. So what is the size of our stack? The size of stack is 2. So the size of answer would also be 2, right? Its size would be what? Its size would be 2. And what we will do, we will start populating our answer from the back side. Why we will start populating it from the back side? The reason is that because these values are stored in the reverse order, right? Because if I'll pop out this S and if I'll add it at the front and lately I'll pop out this U and I'll add it over here, then it will give us a wrong answer, right? We wanted US, we didn't wanted SU, correct? So what we will do, we will firstly pop this S from here and after popping it, we will add it to the end. Then we will pop this U and we will add it to the front, correct? That is, we will move in this way in order to populate the answer, correct? Now, I hope the solution is clear to you all. So let's quickly code this. So what we will do, we will first of all create a stack of characters and let's call it as container. After that, what we have to do, after that, we will iterate over the given string S. So we will say current is to S. And what we will do is, we will check if the current value and the top value of our stack are the same value, but in opposite cases or not. So you might think that how are we going to check that, right? Because what we were doing over here, we were checking like, if we encountered the small b and if we encounter this capital B, then what we used to check? We used to check whether the value present at the top is capital B or is it small b. We used to check like that, right? So you may ask me that if our stack is containing B, correct? And if I have got the character B, capital B, and I want to add this capital B in my stack, but how am I going to check whether the top value is small b or what is it? How we will check it, right? So what we can do is, you can write ASCII table over here And you can open up the first result. So what we can see is, what is the ASCII value of capital A? It's 65, correct? And what is the ASCII value of small a? It's 97. So let's open up the calculator. And what is the ASCII value of small a? It's 97. And what is the ASCII value of capital A? It's 65. So if we subtract them, what we are getting? We are getting 32. Okay. Now let's subtract the ASCII value of small b and capital B. So what is the ASCII value of small b? It's 98. And what is the ASCII value of capital B? It's 96, right? So let's do this. So if we subtract 98 and 66, what we'll get? We again got 32. Now let's see for some other variable. Let's take this r. Okay. So let's do it. So what we will get? If we have small r, so its ASCII value is 114 and the ASCII value for capital R is 82. Correct? 82. So what are we getting? We are getting the difference as 32. So did you notice any pattern over here? So the answer is yes. And what is the pattern? The pattern is that the difference between the ASCII value of all the letters, but in opposite cases, will remain always 32. That is, if you find out the difference of capital A and A, it would be 32. Then the difference of B and small b would be 32. Similarly, for D and small d, J and small j, S and small s, U and small u, Z and small z, it would always remain 32. Correct? Provided that you are taking the absolute value. Correct? Because if you subtract like capital A, the ASCII value of capital A minus the ASCII value of small a, then it will give you minus 32, because obviously 65 minus 97 will be minus 32, right? So I'm talking about the absolute value, correct? We are not considering the sign. So whenever we get that, if our stack, that is if our container is not empty, and what we discussed, that the absolute value of the current value and the top value of our stack, correct? That is the top value of this container. If it is equal to 32, then what does it mean? It means that they are the same character, correct? But in different cases, right? It means one of them is an uppercase letter and the another one is the lowercase letter. So whenever we get a same letter but in an opposite case, what we do? We simply remove it from the stack, correct? So what we will do? We'll say container dot pop, correct? Now, if my stack is empty, correct? If my stack is empty, or if the absolute difference between the top value and the current value is not 32, then in that case, what we will do? Then in that case, we'll simply add that particular value to our stack, correct? So we will say that container dot push current, right? Because in case if our stack is empty, then we can't do any more check, right? Because initially when we were having this u, at that particular time our stack was empty. So if our stack is empty, we don't need to do any checks, right? Because we don't have any top value. So if our stack is empty, we'll simply add this particular value to our stack, correct? And if the difference of this value, that is the ASCII value of this and the ASCII value of this is not 32, then what we will do? We'll simply add this. Why? Because after adding this s, because we can see that what we had in our stack, we had capital U and we added this small s to our stack. And why did we added it? We added it because their differences was not 32. So what does it mean? It means that even after I'll add the small s, the string will still remain great, correct? Now what we will do? Now we will create a answer variable, and what would be its size? Its size would be the same as the size of the container. So we'll say container dot size. So we will create an answer of size n, and let's take a pointer I, which would be initially pointing at I by n minus 1. And why is it pointing at n minus 1? Because I explained that the values that we will get in the stack, it would be in the reversed order, correct? So we will start populating our answer from right to left. That is, we'll start adding the values from the end and then we'll move towards the start, correct? That's why I have taken this I pointer pointing at the end of the answer, correct? Now what I'll say? I'll say that while our container is not empty, what we have to do? In answer of I, we will add container.top, correct? And after I have added that particular value of our stack, what I'll do? I'll remove that particular value from my stack, correct? And after that, we will decrement this I pointer, correct? That is, we'll move it towards the beginning. And finally, what we'll do? Finally, we'll return the answer. Additionally, we have to also mention over here that is initially our answer would be of size n. And all the value in our answer, I'm representing it as a dot. That is, let's say if the size of our container is 2, then in that particular case, we have created an answer variable of size 2 such that answer is containing 2 dots. Okay. And what I'm doing over here, I'm iterating over the container in order to add the values of the container in our answer starting from the rightmost side. Correct? That is, in this case, what we were having this S and U. So how we will add? We will firstly add this S, and after that we will add this U over here. Correct? Sorry, it would be empty over here. So let's quickly run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity. So if we consider the size of the given string as n, then the total time complexity would be order of n. How? So we can see over here that what we are doing. Over here we are iterating over all the elements of the string s, correct? So if we have a total of n elements present in s, then what does it mean? It means that we are going to process all the n elements, correct? So it's going to cost us a time complexity of order of n. Fine. Additionally, we can have a case in which what can happen? We can have a case in which our given string is already a good string. That is, if we can have something like this. So we can see that this is already a good string. Why? Because all the adjacent characters are although the same character, correct? But they are in the same case, right? They are not in the opposite case. So what will happen? In our stack, we will have all these 8, correct? So we will be running this while loop again for what time? We'll be running it again for order of n time complexity, correct? So what would be the time complexity? It would be order of n plus order of n. That will give us order of 2n. And since 2 is the constant, so we can ignore it. So we will ultimately get the time complexity as order of n. Now the space complexity would be order of n as well. Why? So we can see that we are using a stack over here, correct? And in the worst case, what we can have? In the worst case, the given string S can already be a good string, correct? That is, it could be something like this, in which all the letters are same, or it can be different as well, but all of them are in the same cases, correct? So what will happen? Since they are all in the same cases, so we will have a total of n entries in our container, correct? So it means that in that case, we'll have a space complexity of order of n, right? So that's all about today's Daily LeetCode challenge. Thank you.